Okay. All right, so here we go. So we're looking, I'm just going to start question number 1. So I'm actually starting in your homework. This is section 2.1. Hopefully this and the next, we'll see how we do, are going to be due on Wednesday. So here's your first question will be just like this. It'll be different numbers. And in fact, this is the question. I think we need a little more room. Let me get a fresh screen here. Whoops, that's not my fresh screen. So number 1, is 213 a solution? So is 213 a solution of, what is it? Y equals 7x minus 1. Okay, is that a solution of y equals 7x minus 1? So how do we answer that question? What do we do? It's a yes or no. How do we figure out if it's yes or no? Yeah, you guys are totally right. Plug that in, huh? So this is x and this is y. Remember, it's always alphabetical order. X is first, like the alphabet. X is before y. So you plug whatever number's here in for x and whatever number's here in for y. So I get 13 equals 7. And when you plug in, I'll put parentheses. Remember that when you plug in, you put parentheses into the number you're plugging in there. Minus 1. Did I do that right? Yeah. So now we just got to work that out and see if it's true or false. So 13 equals 7 times 2. You can use calculators for everything in here, even on the test. So 13 equals 13. Yeah. So this one's true, yes, whatever. I don't know if it's yes or true, either one, whatever. If they were not equal, we would say no or false. So what that means is 213 is a solution to that equation. It makes the equation true, doesn't it? Is that good so far?
Just 1 second. I'm sorry. I'm a little slow.
Yeah, no problem. So number 2 is the same, so I skipped number 2. It's the same kind of question. I try to do at least one of every type. Number 3 is asking me to graph. They have a little graph system there, and they want me to use the graphing tool to graph. Our exams will be multiple choice, but I'll explain more as we go. So how do we graph? Does anybody remember anything? We're not assuming. You don't have to remember. We'll start from the ground floor here. But does anybody remember anything about graphing? Like, how do you... First off, is the graph going to be like a circle or a U shape or a line? What is the graph?
Linear.
Yeah, how do you know it's linear? It's going to be a line. How do you know? What about the equation is screaming out, I'm a straight line, not a curve? Linear. What does that mean, linear equation?
It's straight equal sign.
Well, there's other things that have equal signs that aren't lines.
Isn't it like if it's negative?
No, it's not the negative.
Why?
It's x and y don't have powers on them. If x and y are, if this was x squared, that would be a U shape all of a sudden. So when x and y are just regular, x and y, x first power, they have understood invisible 1 powers, don't they? Their first power, regular x and y. When they're regular x and y, that's always going to be a line. It's what we call a linear equation because the picture is going to be a line. Yeah, so later in the course, we'll put powers on the x's and y's, and then they'll bring in the curvature. So what brings the bending in the graphs is higher powers. Or absolute values or other funky things. If you just have a regular x, regular y, nothing else weird, it's always a straight line. All right, so how do we, so we know it's a straight line. That's a big leg up just knowing that. It's a straight line. Since it's a straight line, how many points do you need to find? How many dots? Yeah, just 2, huh? All you need is 2 dots. If you can just find 2 points, that's enough to make the straight line, isn't it? So how do we find 2 points? Anybody know?
Y-intercept.
Yeah, what's the y-intercept? Yeah, exactly. This number off to the right is what's called the y-intercept. And that you start there, start up 6 in the middle. Why up? Because it's positive. If that was negative 6, I would start down 6. In the middle. What do I mean in the middle? I mean, I'm going to go right. Do you see where 6 is? Right there? See how that 6 was between 4 and 8? So these jumps are going by 2s, aren't they? See how that is? 2, 4, 6, 8. They're not showing the 2. So this must be 6 right there, huh? So that's my first dot. I'm halfway there. I only need 1 more dot. So the first dot, whatever number's off to the right, starts up 6 in the middle. Now, how do we get to the second dot? Yeah, where's that?
1 over 1.
Yeah, it's the fraction that's right here in front of x. Of course, there's nothing in front of x. So what numbers could I put there that wouldn't change anything. 1 over 1. Yeah, remember all that? Because 1 over 1 is just 1, and 1 times x is just x. Right? So we do that. That what I just did there, we do a lot of that in math. We have invisible ones, like, everywhere. Do you see why that's okay? Because I didn't really change anything. I call it plastic surgery, just to put a weird word in your mind. We're removing the wrinkles, making it look different without being different. That looks different, but it's not really different. 1 times x is still x, isn't it? That's the same as x, right? 1 times x is just x. So now you might think, well, could we put any number there? Could I put 7 over 1? No, that would be different. 7 over 1, that's times x. That's not the same as x. But 1 over 1, yeah, that's just 1. Yeah, you actually could do that, huh? Yeah, so we just do 1 over 1 because we need something there. We need a fraction there to know how to find our second point, but we can't change the problem. So 1 over 1 is the same thing. All right, so what is that? That's the rise and the run. That's the slope. Remember that from earlier days? Rise and run, slope. So that means from the 6, from our first dot, I'm going to go up 1 and over 1. The problem is these jumps are going by 2s, aren't they? So let me see. I don't know if I have room to do a very good job on this. I'm going to have to go up half a jump. I can't even, it's just too small. I wish they wouldn't have made it this way. I'm going to go, in fact, I'm going to do this, guys, if you don't mind. I'm just going to come down here. 1, 2, 3, 4, 5, 6. So there, 6, and then I go up 1, over 1. Up 1, over 1. There's my second dot. Connect the dots. You've got your straight line. Does that make sense what we did? So the first dot was an up 6 in the middle, because of that 6 off to the right. And then from that dot I went up 1, over 1. Rise, run. Up 1, over 1 to get the second dot. Connect the 2 dots, straight line. Now, the system will make straight lines for you pretty easily. All right, let's try that. Y equals 1/4 x. In fact, I'll just go to a fresh screen here. Y equals 1/4 x. Can you graph that? It's going to be another straight line. Where do we put our first dot on this one? Yeah. Notice there's no number off to the right. So here we go. I got to do plastic surgery again. I got to make it look different without being different. Can I put like +3 out here? No, that would be different, right? That'd be a different question. Could I put +1 out there? I see that mistake sometimes. No. Adding 1 changes things. You can't add 1. You can multiply by 1. Multiplying by 1 doesn't change anything, right? But you can't add 1. And the number off to the right needs to be added, right? Let's look back here. See how this last problem, the number off to the right is an added or subtracted number? Right? So I have to add. So what number can I add that won't change anything? 0, right? Adding 0 changes nothing. So that's what you do. Take it from there. So now you can do it. Okay, so we start here. So that would be right at the origin at a height of 0. And then we come down for the other ones. Rise over run, that's the slope. That means go up 1 over 4. So up 1 over 1, 2, 3, 4. Up 1 over 4. There's our second dot. Everybody see how I got that? So the first one starts at 0, because that's the number off to the right. Then up 1 over 4 for our second dot. And then the machine will automatically connect the 2 dots to make your straight line. Easy enough. Questions? All right, let's try number 5. 5 is 3x minus 9. And again, if I'm going too fast, this will be on YouTube later. So where do we start?
9.
Yeah, start. Yeah, that's going to be down 9 in the middle, huh? So it's not left or right, it's down or up, huh? So it's going to be down on 1, 2, 3, 4,
So you
5.
put down RS?
8, 9. Well, negative is down, positive is up.
Oh, because it's -9.
It's negative, yeah. Yeah, exactly. Yeah, so down 9 because of the negative. So that's our first dot. And now how do we get our second dot? I've only got one number. I need, the 3 is, I need to do plastic surgery again. I need to make it look different without being different. I need 2 numbers, don't I? I gotta have a rise and a run. Yeah, can you say, hey, this is the same, just do that. 1 over 3. No, 1/3 of a pi is not the same as 3 pies. That's an illegal change. That's not just plastic. That totally changes. But you do it this way, huh? 3 divided by 1 is 3. That's the same as 3. It just looks different. We do that all the time in math, don't we? So rise over run. Go up 3, 1, 2, 3, over 1. Up 3, over 1. Connect the dots. We're done. So it was up 3, over 1. Rise over run. It's all good. Remember this is coming back to you? Graph and straight lines? Different. What is different about this one? Why do we have to do something different? Yeah. What are you going to say? What were you going to say?
Both variables are one's negative.
Yeah. What do we got to, what's the look we have to give them? Y equals, yeah. We got to get that Y alone. Did you notice? Look back here for a second. See how this one, Y was alone on the left? See the one before it, Y was alone on the left? Etc. Yeah, you have to get that first. So first, get Y alone. First, get Y alone. Okay, so how do I want Y equals. I don't want X over there. So how do I get Y alone? What will do that? Yeah, subtract that X, huh? Yeah, because it's an equal sign. So I do the same thing to both sides of the equal sign, right? If two things are equal and you treat them the same, they've got to be equal afterwards, don't they? That's what we do all the time in math. Do the same thing to both sides. This cancels. It gets Y alone. Now what's on the other side? Minus X minus 4. You can put the minus X at the back. It doesn't really matter. Typically we put the X's in the front, just what we're used to doing. Either way is fine. So we get to there. Now we've got Y alone. Can you graph from there? Let me let you do it. So find your starting dot and do your rise over run. That negative in front of the X is going to be a little tricky. Let me see if you remember how to do that. We have to have two numbers, huh? We have to have two numbers in front of that X. But we can't change the value of anything. So what do I do when there's nothing in front of the X? 1 over 1. Right? Because we got two numbers. So 1 divided by 1 is just 1. So we haven't changed anything. But notice there's only one minus sign.
Yeah.
But that's true, right? So I can't put two minus signs. Why? Why would it be wrong to go, well, just make it negative 1 over negative 1? That's not the same, is it? Why not? Two negatives is positive. I suddenly changed the problem. I made it positive. That's not okay. No, we have to have, remember, it has to look different, but not be different. That looks different, but it's the same. One negative is negative. 1 divided by 1 is 1. 1 times X is still just X. So now I have my two numbers. I can do my rise over run thing. So let's do it. So let's start at negative 4. 1, 2, 3, 4. Start at negative 4. That's my first dot, right? Down. Negative is down, positive is up. And now how do I get from there to my second dot? Rise over run. How do you rise negative 1? You go down 1, don't you? So I'm going to go down 1 over 1. Down 1. Because the bottom is a positive 1, isn't it? Yeah. So it's still to the right. It's down and right instead of up and right. And so let me not say too many things too fast. Are we good? Good to there. So rise negatively means go down.
And
down,
you got a
one,
negative because we changed it to a minus X up there, so that the one that you're moving over is going to be a negative on top.
Yeah, and why did I put it on the top? Here, let me draw the thing first. There's our graph. Yeah, your question is a good one. So first off, yeah, I subtracted X from both sides because I wanted to get rid of that other X. Right? To get rid of this X, you had to do the opposite sign. Right? This was a positive X. So to get rid of it, I had to do negative X. So I wanted to get Y alone. I wanted to get rid of that X. So I had to do it to both sides. So I got Y alone. But now, yeah, there's one negative sign. I happen to put it on the top. That's what I think is easiest, is just to leave the minus on the top. That way, you just know it's down, and then it's right, because the bottom is positive. But it actually is okay. I don't think it'll be easier, but I want you to know it is okay if you put that minus on the bottom instead. This would be okay also. Let's do it to make sure it's really right. So now notice I put the minus on the bottom, and the top is positive. It's still negative, right? 1 positive, 1 negative is still negative. It's still the same as the original. It doesn't really matter where that negative is. When it comes to a fraction, if you have negative, you can have it on the top or the bottom. Only, not both, because that'd be positive, huh? But top only or bottom only, that's fine either way. It's negative. So, but how would that work graphically, though? Yeah, this is rise, and this is run. So starting from here, I would now rise. I'd go up one, but then I'd go back one. I would get another dot, different dot, but same line in the end.
Okay.
See how it would work? Isn't that great? Math always works. It does. Math is just pure logic. So it works. But anyway, I wouldn't do it that way. I just want you to know that's okay. But I think it's easier just to always put the negatives on the top. That way you just go down and right. I think it's quicker, easier. Won't have to think so much about right, left, up, down. You know, it's just positive up, negative down, always right. That way. If you just put negatives on the top. Questions on that one? We good? Okay. So let's try this one. X plus 3y equals 9. Number 7. X plus 3y equals 9. We're here to go over. Yeah, so we got to get y alone. There will be a new step on this one, exactly. Here, I'm going to put in, you don't have to, but I think it might be helpful. The equal sign is like a wall separating. And you know what our goal is, get y alone, right? We want to get y alone. So what do we do to get that y alone? Yeah, start by subtracting that x, huh? So subtract x from both sides, correct. And this will be 3y. So I always put the x in the front. You don't have to, but it might be easier. And it's a plus 9, by the way, because there's no sign on the 9, so that's positive. Good so far? Now we have one more step. We need to get that y alone. Divide everything. Yeah, now why is this one divide? Why don't, you're right on the money. Why don't I subtract 3? It's wrong, huh? Why? Why is it I divide instead of subtract? Yeah, because it's attached, it's multiplying exactly. When that 3 is right next to the y, it means times, huh? When there's no symbol in the middle and two things are right next to each other, that means multiply, and the opposite of multiply is divide. That's why it's divide. Yeah, so you guys are right on the money. Divide. Now, when you divide, you have to divide all of them, right? Because remember, the equation, the two sides are equal. So whatever you do to one side, you have to do to the other side, all the parts of the other side, and then they'll still be equal afterwards. So what do we get? Negative x over 3 plus, and what's 9 divided by 3? That's just big old 3, huh? That's almost the look we need. Remember, we need two numbers here and a number back there to graph. So one number's missing. What do I put there? 1. Yeah, you know it. So now you got all your numbers. Can you graph it there? So go ahead and graph it now. Now it has the look we need. Now we can graph it. All right, so where do we start? We start at up 3. It's positive, so it's up 3 in the middle. Yeah, and then rise over run there. This is rise. This is run. So yeah, so down 1, over 1, 2, 3. So down 1, over 3. Connect the dots. There's our straight line. Is that good? Questions I can answer on that? Some of that coming back to you? It's all foreign. You can. So try that one. Same kind of thing. First off, you got to get that y alone. So if the line, I'll put the wall in. So we got to get y alone. That's our goal. So I always do the adding, subtracting first. It's a lot easier that way. So notice I don't divide by the 6 first. You could, but I guess it wouldn't matter much on this one. But anyway, so subtract 3x. Sometimes it'll make it harder, though. So I always do the adding, subtracting first. Subtract 3x from both sides. We always do the opposite when we're getting something alone. Do you remember that? It's always the opposite. So what do we get then? We get 6y equals minus 3x minus 6. That good so far? And then what do I do next to get y alone? Yeah, divide, huh? Because that 6 right there is right next, so it's timesing, huh? So the opposite will be divide. Whenever you divide, you got to go all three of them, don't you? So that cancels. Y is alone. Now, this fraction can be reduced, can't it? We always reduce fractions. What do you do with 3 divided by 6? That's a half. Yeah, is everybody good with that? 3 goes into 6 2 times. If you want, I divide 3 goes into 6 2 times. Or you could say I divided them both by 3, whichever way you want to think about that. I divided them both by 3, left a 1 on the top, left a 2 on the bottom. Huh? We always reduce fractions. Always. There's really no exception to that. Minus, and then what's 6 divided by 6? Yeah, that's just 1. And see how I put the minus on the top? You don't have to, but it's usually easier that way. Right? When a minus is on a fraction, I just put it on the top. Okay, so now it's got the look we need to make graphing easier. So we go to the graph. So down 1, right there. And then from there, we do rise over run. Yeah, exactly. So we're going to go rise over run. Yeah, so down 1 and over 2. Down 1 over 2. And then we connect the dots. There's our straight line. That makes sense? There'll probably be like 2 of those on the next exam in a few weeks. Multiple choice, just like that. Question like an answer? So we're going to change gears a little bit. Okay, so y equals 2x squared. You can see they're all U-shapes, aren't they? If they're given to me multiple choice, see how, like what I was talking about, when you have x squared, then you get curvature in the graph. So these are U-shapes. How are you going to graph that? Well, later in the class, we'll get, a couple months, really, near the end of the semester, actually, we'll get more fancy about parabolas. Yeah, we'll get more. They'll give us more tricky parabolas. They'll move them around, turn them sideways. I'll give you more specifics at that time. For now, let's just keep it simple. They just want to know which one of those is it. It's just multiple choice. What I would suggest is just simply making a table. Just going to keep it as simple as possible. Later, I'll tell you more specific things about how to pinpoint the vertex and some other things, but we don't need all that for now. I would just make an XY table. Have you done that kind of thing before? Where you just plug in some points, and all I need is if I can just get 2 dots, I can figure out which graph is right. It's about all we need. This is just to kind of get your feet wet. Just make sure you're generally comfortable with making tables and figuring out a graph. So I would I can plug anything I want, any numbers I want in for x. Doesn't really matter. So I'm going to do the easiest ones I know. What's the easiest number we know? 0, followed by 1, followed by maybe 2. 0, 1, and 2. I always plug in 0, 1, and 2. For x, and then I'm going to plug that into this equation in the x slot. I'm going to put parentheses and plug it in, and then I'll find out what y is. So y equals 2 parentheses 0 squared. That's just 0, huh? Right? 0 squared is 0. 2 times 0 is 0. So that's just 0. What does that mean? That's the dot 0, 0. That's the origin, huh? See this 0, 0 here? That's over 0, up 0. Everybody see what I did so far? I just took that equation they gave me, y equals 2x squared, and I put 0 in for x. This is the x slot. Worked this out. 0 squared is 0 times 2 is 0. Y is 0. So that means x0 leads to y0. They go together. The point 0, 0 is a dot on the graph. All right, let me get probably only need one more dot, really. Let's do one more. Y equals 2 times 1 squared. I just put in 1 for x. Just plug it in for x. Let's work that out now. 1 squared. 1 times 1. This is 1 times 2 is 2. So the whole thing works out to be 2. Yeah. So that would be over 1 up to, you familiar with finding dots on graphs? Right? The first number, it's over 1 up 2. It's the opposite of slope. Do you know what I mean there? The first number is over. The second number is up. That's the opposite of slope. Look back at slope. The first number was rise. The first number was up, huh? The top number was up. The bottom number. So when you have a fraction, a slope, the top number is up, down, rise. The bottom number is sideways. But when you have 2 points, 2 numbers in a parenthesis, the first is x. X-axis is sideways, huh? The y-axis is the up-down one. So the first number is the over. The second is f. So you got to keep that straight, you know. Those are very similar, but they're backwards, aren't they? So the fraction, the slope, rises on the top. You go up first, then over. But when you have the 2 numbers with the parenthesis comma thing, the first number's over. The second is up. So that's the dot over 1 up 2. It's not a slope. It's just another dot over 1 up 2. Well, really, that's enough information to figure out which answer is right. I don't need to keep going. Only one of those 4 graphs has the point 0, 0. They all have the point 0, 0. Well, no, they don't all. Yeah, which ones have 0, 0 first off? Which ones go through the origin? Yeah, it's either B or D. Those are the only 2 that hit right at the origin. See right there and right there? The other ones miss. See how C is higher than the middle and A is lower than the middle? So it's not A or C. And it's going up, so which one is it? It must be B. We're done. B is the answer. Everybody see how I determined that? So 0, 0, origin. C doesn't go through the origin, neither does A. So it's either B or D. And then I did one more point, over 1 up 2. It's got to be B. That's all you need to do. Just get a couple of points until you can tell which graph is right. If you did a whole bunch more points, you'd find dot, 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 dot. You know, that's how it got the U-shape. There'd be millions of dots that would make that U-shape. I just don't want to do all those dots. But you could do it. I mean, if you kept plugging in 3, 4, -1, -2, you'd find all those dots if you did all that work. All right. So on try number 10, y equals, I'll read that, x squared minus 8. Try that one. Could that be answer C? No, because that's a straight line. And we have x squared, which you know makes a U shape. Huh? So we know it's not C. It's one of those U shapes. C. So if you can just tell, great. If you want to make, you can make a table, XY table, like we did. So that's generally my suggestion is on these ones that are not lines. Yeah, maybe I'm not being very clear. When it's not a line, right? This squared tells me it's not a line. I make a table, an XY table. Are you seeing that? So I've given you today 2 strategies for graphing. There's many more, but just 2 today. For the ones that were lines, we got Y alone, didn't we? Let me look back and make sure I'm being clear here. Like this one. See, this one, I knew from the word go that it was going to be a line back on number 8 because they were just regular x and regular y. It wasn't x squared, didn't have absolute values, didn't have anything weird. It was just regular x, regular y. So then I go, oh, okay, you got to get y alone. And then start at -1, rise and run, and get your line. So when they're just regular x, regular y, we don't make a table, do we? I mean, you could. There's another method, but I think it's easiest to just get y alone. And you can get your 2 dots and get your line. But if it's anything that's not a line, like x squared, I make a table. So that's what I'm saying. So when it's not a line, make a table. And what's the first thing, the easiest number to plug into the table? 0. Just plug that on in. And then we get y equals 0 squared minus 8. And 0 squared is 0 minus 8 is just -8, huh? So that's the point 0 minus 8. So which of those 4 graphs have the dot over 0 down 8? Right there, yeah. Looks like the point over 0 down 8. It's the only one that has a dot that's over 0 down. It's got to be D. And it's a U shape. That's all I need. I don't even need any other points. Is that making sense? So if it's regular x, regular y, get y alone, do the slope thing, find your 2 dots for a line. If it's x squared, or like the next one, absolute value, so it's not going to be a straight line, make a table. So let's do that next one, the last problem in the section. Number 11, y equals absolute value x minus 4. So it's not a line. Why not? Because it's got those weird absolute values. Whenever it's got x squared or absolute value or something weird, it's not a line, so make a table. So make an XY table and just plug in anything you want. Zeros, 0, 1, 2 are good ideas. What do the absolute values do? Makes it positive. Remember, absolute values make things positive? Remember that? So we'll see as we go here. So put in the 0. That's the absolute value of -4. What's the absolute value of -4? Yeah, regular 4, positive 4, huh? It just makes it, by the way, it makes it positive at the end. You don't make it positive in the middle. You don't do it right away. You at the very end, final answer, then you make it positive. Let's do the next one. So y equals, now we're going to plug in a 1. So again, I don't make it positive right now. I first work out the problem and make the final answer positive. That's different. So first, 1 minus 4 is -3. And then the absolute value of -3? Plain 3. Positive 3. Is that good? So let me put those points over 0 up 4. There's over 0 up 4. Remember, first number's over. This side is over. Second side is up. Over 0 up 4. And then over 1 up 3. There's another dot. Now, anybody know absolute value graphs? They have a certain look. X squared graphs are always U shapes. That was like this one, right? X squared are always U shapes. Absolute values, anybody know? What's an absolute value graph always look like? It does a V. Yeah, straight up or down. It's a V. It's going to be some kind of V. Let's see if we can